This is All India Radio. Power of Listening. Under the series, tonight we take you on a journey to the world of yet another magnificent facet of the traditional Indian knowledge systems. I'm Manoj Mainkar. In our last episode, we discussed about the earliest astronomers and books written by them on astronomy and space sciences in general and Acharya Aryabhatta in detail. In today's episode, we shall continue to be discussing about a few more astronomers and their contribution on the knowledge of space sciences in ancient India. The expert on the show is Dr. Abhirup Datta, Indologist and Professor of Astrophysics, IIT Indore. Talking to him is Dr. Manas Pratim Das, Science Communicator and Writer. Stay tuned.
Welcome listeners to another episode of Power of Listening. Today we have with us in our studio Dr. Abhirup Datta, Professor at IIT Indore in the Department of Astronomy, Astrophysics and Space Engineering. He is here to talk about our ancient heritage in the field of astronomy. He has already been a part of this series and has spoken on the contributions of Aryabhatta. Today, we'll proceed further and talk about Barahamihir as well. To present a proper perspective, we'll take up one celestial event that is so dear to us. And when it happens, it becomes a spectacle for all of us. We take out our special glasses and watch the astronomical event. It is the eclipse that I am referring to. At one point of time, it was thought to be something very ominous. But as scientists like Aryabhatta started dealing with it, started calculating the motions of the heavenly bodies, it became clear to him that there is nothing ominous about it. And he started demystifying the whole thing. Now, we would like to ask Dr. Datta how it happened and how the calculations were refined and how did the whole process proceed from Aryabhatta to Barahamihir and how did we get a better understanding of this eclipse?
Thank you. As we said that the astronomy in India is a very old culture almost and the oldest science which people have started doing. So the traces of astronomy in India can be found in Vedanga Jyotisha. Now, as you know, that was too early, about 1400 BC. Okay, so at that time there were very little understanding of how the celestial bodies move against each other. So it took almost quite a few hundred years till Aryabhatta, who was around 499 AD, who was very scholastic, and I spoke about it in the past episode, and who actually did all the mathematical calculations of position and movement of heavenly bodies. And he actually proven and able to predict also the timing of the solar and lunar eclipses. Now, as you know, that in our traditional or mythological views, these events were considered to be really ominous. We were not even allowed to eat any food or drinks at these times. But when he actually predicted the next eclipse, this was a time when people understood there is something scientific about it and nothing ominous like some particular named demon eating up the bodies and again gargling it out. But essentially, even after proof came from Aryabhatta, those names, Rahu and Ketu, are still there. So what are they? Basically, if you see that the earth revolves around the sun and the plane is called ecliptic plane. But the moon also revolves around the earth, but the plane is about little bit tilted to the plane of the ecliptic. Now at the two junctions, when the moon is crossing the ecliptic, there are the two nodes. So it crosses once in the one side of the earth and it will again come back around the earth and again it will cross and go up the ecliptic. If these 2 points are called the nodes, then these two are called Rahu and Ketu. And basically when these 3 conjunction will happen, these 3 particular bodies, moon, earth and the sun, which is the cause of lunar and solar eclipses. So lunar eclipse is formed when essentially the Earth itself comes in between moon and the sun, and solar eclipse when moon comes in between. This we all know. So because this happens when at the nodal points of this moon, so this Rahu and Ketu concept is still there, but they have been can be explained scientifically. Even though scientists or astronomers in the past have been able to demystify the things, they have not exactly contradicted the traditional feelings because of maybe mass conception or mass protest or something, which is now slowly going out.
Okay, it means that Aryabhat himself had gathered a lot of data about these celestial events, because as we know from at least astronomers of the recent past, like Kepler, like Tycho Brahe, they had tables spanning thousands of pages. So Aryabhat himself must have gathered a lot of data. Could you please shed light on this?
Yeah, I mean, unfortunately, there is no mention of any observation in these texts. The text which we referred last time also as Aryabhatiyam, the major work of Aryabhat, or even we will be talking about the commentaries on those explanations of these Siddhantas by Varahamid, the major proponent who has actually spread the work of Aryabhat. Even there also there is no mention of any particular telescope, use of any instrument. It comes very late, quite late in the day after Brahmagupta or so, at least about 100 years later, when they have access to certain positional astronomical observatories, like what we have in Jantar Mantar, what we called after Swai Jai Singh too. So similar things existed there. It is again recorded that some of those yantras were available at later times. But unfortunately, the texts which we get from this age of work around 500 AD or so, there is not much of mention about those. But I'm sure, I mean, they would have to confirm, and they'll probably confirm by some methods. They paid more attention to the mathematics, the trigonometry and the geometry part of it, and then the observation part of it, unfortunately.
Right. Now the mathematics part of it, which of course involves a lot of calculation, was refined through the years. We don't hear of any giants like Aryabhat just after him, but Varahamid is another fellow, a little junior to Aryabhat, who did calculations and who refined those calculations in a better way. And if you could please tell about him, how he did this.
Yeah. So Varahamid actually follows Aryabhat, and much of the work, as you know, of Aryabhat was done as early as his age of 23. So those were available. And what Varahamid did is enormous, is his explanation of what the work of Aryabhat was. So actually the writings of Varahamid became more famous than Aryabhat himself. And so one of the major work of what Varahamid did, for which we still regard him now, is Surya Siddhanta. Actually, there are several versions of Surya Siddhanta. So to explicitly mention his work separate from others, typically we say it's Surya Siddhanta. And that is still regarded as one of the basic books, texts by which the calculations are done. People can follow and continue working on the same system again and again. But apart from Surya Siddhanta, there is another book which Varahamid did, was Pancha Siddhanta. And here basically he has amalgamated 5 different Siddhantic views into one form of text. So according to the books, these 5 different Siddhantic views, Paulisa, Romaka, Vidisha, and Saura and Paitamaha. And this Pancha Siddhanta basically actually amalgamates all these views, and this comes in a single form of text. Out of which Surya Siddhanta still remains, as you said, the basis of our calendric system, and still regarded as the most revered book on positional astronomy still did.
Listeners, you are tuned to the series Power of Listening, and today we are discussing the contributions of Aryabhat, Varahamid in the field of astronomy. and in fact informing ourselves about the great heritage of Indian astronomy. With us we have Dr. Abhirup Datta, professor at IIT Indore. And the next question is about the celestial sphere. Now, to a layperson, the earth, the moon, the sun traverses a path which is sort of predetermined. To a scientist, he draws circles, he determines points of intersection, and even the point of intersection is moving, that is not again fixed. So these things all come into the fold of the celestial sphere. So if you could tell us about how it was developed and how it was refined or modulated later on, that would be helpful for the listeners.
Yeah, this is a very, very good point, because as we see, for a layman looking up in the sky, we see the entire sky basically being projected onto a plane, a single plane. It looks like as if the sky is made of like a thin shell, and all the stars and galaxies and everything moving on the same plane. It's like projecting. You actually make a movie in 3D, but you are actually projecting into a 2D screen. Exactly the same concept. But still, I mean, how will you follow so Earth is moving with respect to sun, the sky is also moving. Okay, how do you fix this? Unless you have a proper system, you cannot go about it. So, and this celestial sphere is now the basic concept when you start teaching somebody, student, undergraduate level, or even school kids. You have to teach from the celestial sphere itself. Now, what basically the underlying concept is very basic, is that you consider because Earth is a sphere, so in projection we see entire universe in a spherical form. So the sky remains as it is, but it appears to move because the Earth itself is revolving. And here also there is a very nice analogy which Randheer also gives, that as it like when you're rowing on a boat, you see in the banks the trees are moving against you. You appear to be still with respect to yourself. That's exactly what it appears. So the stars appear to be rising and then setting, and that's all because of the rotation of the Earth. Because Earth itself can be approximated to be a sphere, so we consider the entire sky and other celestial objects to be on a celestial sphere. By doing that, what we now can do is we can fix the coordinates of those particular stars, galaxies, constellations in this celestial sphere. Okay, and of course, as we all know, we are privy to the geographic latitude and longitude concept. Similarly, there will be another similar coordinate system of right ascension and declination in the celestial sphere.
So we are actually blowing up the Earth and taking it to the celestial sphere, and the lines of meridian and longitude are all painted on it, sort of, we are imagining.
Kind of.
So it's a similar thing.
Right. And so basically you can understand that based on where you are located, where is the observer located on the surface of the Earth, based on the position, the things will appear to move. It will move in the finite speed, but it will appear on the particular part of the observer's sky above the horizon, because the observer cannot see anything below the horizon on either side. So that is a restriction. So based on the observer's location, a particular star or a constellation will appear in this part of the sky at a particular time. Okay. So typically what we have been seen, that we draw an imaginary line, or our longitude basically, which is connecting our north and the south, which is we call the meridian or local meridian. And any object which can be viewed from that particular part of the world will, any time of the day, will actually cross this local meridian. And when it crosses this local meridian, we call it a transit. So just a minor concept, that so every object which can be viewed over 24 hours from that particular location will transit this local meridian once in the day or night. Now, interestingly, all these concepts and referring to these particular concepts are available in even works of Aryabhat and Randheer as early as that. In fact, in those times, the prime meridian of India was considered to be passing through the holy city of Ujjain in Madhya Pradesh, about 75 degrees east. And all the astronomers who has worked in India actually has worked with respect to that particular prime meridian. We have not found anything yet which is based on any other work. So Varamir, be it Aryabhat, be it later on Bhaskara or Brahmagupta, all have considered that particular meridian to be the prime meridian of India. And there is a concept of something called Lanka, which comes in the texts very often, which is basically, if you are considering the celestial equator, that will be some angle towards the south of the Ujjain, because it is in the north of the equator. That particular intercept of the equator and the prime meridian is considered to be a Lanka. So that they basically considered a couple of these nodal points, and with respect to that, they used to do the calculations. So Lanka is not actually the Sri Lanka in the south. It is a particular point in this imaginary intersection of the prime meridian and the equator. So this concept keeps coming back. There are a few others which are a little bit different from how the way we do current positional astronomy, but they were all prevalent at that particular time. So as you were saying, these things were elaborated and heavily used in times of Aryabhat and Varamir.
So we won't say that we have got a firm grip on the concept, but at least we are trying to understand what role the celestial sphere played, what role the points of intersection played, and what was the utility of having the meridians painted on the celestial sphere, imagining the meridians and the latitudes as we have it on Earth, as given by us to scholars of geography. We are having those and what utility they had. We are trying to understand these things. Now, on to the next question. And here we would like to bring up another celestial event, and that is the precession of equinoxes. Now, Dr. Datta, as we already know, there are not two but three motions of the Earth. One motion gives rise to day and night. Another brings the seasons or completes the year. And the third is a little different. It's like the spinning top. When the spinning almost comes to a halt, the way the top behaves, if we can imagine an axis through the top, the rotation of the axis can be called precession. That much we know. But the precession of equinoxes, that presents a difficult concept to us. If you could elaborate and tell us what role this played in Indian astronomy.
Yeah, that's a very valid question. So, as you said, brought up the analogy with the spinning top. Actually, this is a very beautiful analogy, and as the top spins, it actually has a rotation, it has a precession and a nutation. And of course, in addition to that, Earth is revolving around the Sun. That is the third motion. So what happens? So if you look at what precession means, basically, if you look at the point of contact between the spinning top and the ground or wherever it is spinning on, you will see that that point is not fixed. That point actually changes. If I have an imaginary ink, that wherever that point touches on the ground, the ink will make a mark. You will see there is an interesting motion or almost an orbit-like feature which appears depending on if the motion of the top is chaotic or not. I'm assuming it is a well-behaved top and it is doing a proper motion.
Meaning the feet of the top will paint an orbit on the floor.
Correct, yes.
Right.
Similarly, you can imagine that Earth has an axis which is tilted, not exactly perpendicular. It is tilted by 23.5 degrees, and so it is pointing to the, if you imagine a line drawn within the sphere or perforated through the Earth, connecting inside the geographic north and geographic south, so the north gets pointed to a particular part of the sky. Now, the reason is, this is interesting because this location of the geographic north has been painted on this imaginary sphere of celestial sphere by position of a star. What we say in our Indian language is called Dhruvotara, or the star which never changes its position. Now, that is actually interestingly not an absolutely right concept, because it points to a particular location, and at that particular point, whichever the star is that particular location will be called as a pole star. But pole star has been a very guiding force to all circumnavigations done on the Earth as early as from the earliest we know.
The sailors took help of it.
The sailors took help of it. We didn't have the extravagant use of GPS or location at that time, neither anything else. So the sailors in the middle of the sea or ocean only had rely on the pole stars. But interestingly, to relate it to this precision of the Earth's motion, what happens is these pole stars are not exactly one particular star. It's a particular location which keeps on changing because of this precision of the Earth's motion. And it also again makes an orbit, which is roughly 25,000 years. It comes back to the same point. So I can give you some hint that currently what the pole star which is there is called Polaris. But that doesn't mean it will stay there for the entire time. It will again move away and it will again come back to Polaris after 25,000 years. But we will not be there to witness that.
Meaning the axis will point to some other star.
Correct. Because it makes an orbit in the imaginary sky.
But to a sailor, it's a blinking star only.
It's a blinking star.
But an astronomer knows that the star has changed.
Right.
And that gives a proof of this precession of equinoxes.
Correct. Like there's a fact that around 14,000 CE, there will be Alpha Vega or Alpha Lyrae will be the brightest star in the pole position. It was there around 12,000 BC. So it will again come back in that particular point. Like during the civilization of Babylonia, Mesopotamia, Indus Valley, Alpha Draconis was the pole star.
So when you said 12,000 BC, and again connected it to 14,000 AD,
correct,
that again means that the period is around 25 to 26,000 years.
25,800 years roughly.
Which you mentioned earlier.
Correct, yeah. So that's the beauty, and it basically makes a motion, an orbit around that in northern pole, and whichever the star is there at that particular point will be termed as a north pole star.
So how did the Indian astronomers make use of it?
Indian astronomers basically predicted the motions of this precision. It was not incorporated, unfortunately, in most of our calendric system. In fact, this precession of equinoxes is the particular thing which still confuses us. If you see the differences in prediction of our local Indian calendar system with the more scientific ones, this particular motion or this precision still has to be incorporated to make this. And that is why you see that the dates predicted few hundred or thousand years back now have a gap. So you do not see the same date coming on the same tithi because of the problem that this additional calculation or error has to be incorporated in those systems.
So, Dr. Datta, if I can take a little bit of liberty and say that this is referred to as ayana.
Yeah.
So, if you are taking this ayan or precession into account, you are drawing up the Shayan verse.
Right.
And if you are not taking it into account, you are rejecting it, it is the Nirayan verse. So, that is probably what you are referring to.
Yeah.
And that makes a lot of difference in the calculation of the tithis and the proper timing.
Right.
So, how did Aryabhat and Barahmihir, the two almost contemporaries, contribute to it?
So, basically, this concept of celestial sphere came up at that particular time. So, they have made use of it. They have pointed out several nodes on that celestial sphere. With respect to that, they have calculated this precision. So this precision of the pole star, basically north celestial pole or south celestial pole, actually exists during those time. But how that incorporates in the calendric system, that hasn't been done. But this concept existed, and we find traces of those concepts in their books written by them as Siddhanta.
No, but I would like to know a little more from you. We started by saying precession of equinoxes.
Correct.
We have understood that it is an axis which is not fixed. It's rotating in a particular manner, and that is giving us a different pole star along the timeline. Right. But why are we referring to as precession of equinoxes.
Yeah, if you see what are the equinoxes? Equinoxes, we have solstices and equinoxes. In northern hemisphere, the solstice basically when the longest day, and what happens in the equinoxes is basically equal day and night. So basically, the sun and the earth are equidistant in these equinoxes positions basically. So because of this precession motion, what happens is this particular positions timings can change. And that creates a bit of a, because when you create a calendrical system, it starts from a solstice, ends with a solstice, or starts from an equinox, ends with the equinox. And if the precision of this Earth's motion, this timing changes. Okay.
Meaning the date of the solstice
Correct,
changes.
date of changes. That has to be incorporated because the finer modification in the Earth's motion has to be calculated correctly and accommodated in the calendric system in accurate way to make use of it, to be accurate over a large time. So the error grows as we go away from one year to the other year. And so you don't see the errors in subsequent years, but you see it over a time of 1,000 years or something like that. You see much of a difference happens because you have not added this additional motion into account.
Right. So listeners, I do not have any doubt about the fact that though you might have some difficulty in understanding the difficult concepts that were presented by Dr. Datta today, you have already entangled yourself with the system and you are yearning to know more. And that's the power of the series, power of listening. Today, Dr. Abhirup Datta from IIT Indore, Department of Astronomy, Astrophysics and Space Engineering was with us, and he discussed the contributions of Aryabhat and Borahomihir and elaborated how the eclipse was demystified, how the calculations were done, what role the celestial sphere played, and how we looked at the precession of equinoxes, how we sort of got a hold of it through the years and then integrated it into our calendric system. So thank you, Dr. Datta, for coming to our studio and telling us about those wonderful astronomical concepts and India's contribution in those early years, early phases of civilization. And listeners, if you have any query, you may write to us. Today we are signing off. Till we meet again, good night and goodbye.
Bye.
Astronomy and Space Science in Ancient India. You heard the 34th episode of our all-new series on traditional Indian knowledge systems, Power of Listening. The expert on the show was Dr. Abhirup Datta, Indologist and Professor of Astrophysics, IIT Indore. Talking to him was Dr. Pratim Das, Science Communicator and Writer. This was the second part of the talk on the theme, Astronomy and Space Science in Ancient India. We hope you enjoyed it. This series has been conceptualized by Shashi Shekhar Vempati, CEO Prasar Bharati, and produced by Dr. Pratim Das and Vinod Kumar. Special thanks to AIR Kolkata, Amol, Parth and Randheer Thakur for their contributions. This episode is also available on our official YouTube channel, Akashvani AIR. Be there on the 27th of May, same time, same frequencies. This is Manoj Mainkar signing off from Delhi. Bye for now.